We should have started with acids and bases a bit last year, but due to COVID, we didn't. Okay, so I'm going to go through the grade 11 work quite fast, and I'll tell you what is important and what is less important. But I want to start on the last page, because the last page, I gave you a list of strong bases and strong acids that you must know. Okay, off by heart. Okay, let's start there at the strong bases. It says a strong base which completely dissociate in water into a cation. A cation is a positive ion, and an OH or a hydroxide ion. So if you see an OH, you must know it's a strong base. Okay. Now what that OH is bonded to is if it's bonded to group 1 elements or group 2 elements. Okay, you know where group 1 and group 2 is on the periodic table. If you have an OH bonded to either group 1 or group 2, then it's considered a strong base. Okay, and we call them Arrhenius bases, and we're going to discuss what Arrhenius means a bit later. Okay, so if you see any group 1 or group 2 element bonded to OH, you must think strong base. Okay, so here I give you a list of them, and those that are highlighted are the ones that we use most often. Okay, so you must know lithium hydroxide, sodium hydroxide, potassium hydroxide, they're all strong bases. The rest of them, it's fine, yes, you are late, 4 minutes. The rest of them are also strong bases, but they don't use them that often. Okay, then this one here, you had to study in grade 10, has another name as well, calcium hydroxide. What is the other name for calcium hydroxide? No, its other name is slaked lime. Slaked lime. Okay, so those are all considered strong bases. How do you know it's strong? Because it is an OH bonded to group 1 or group 2 elements. Then on the right hand side we have strong acids. Gone. Strong acid, what is that? It's something that is actually ionized completely to form a hydrogen ion. So if you see there's a hydrogen ion, then you know it's a strong acid. Okay, so if we look there, you see there, you know nitric acid, you know sulfuric acid, you know hydrochloric acid. Yes, you've seen them before. All right, then you can see here is more that I added, but I want you to especially look at those two. Okay, if you look on the periodic table, where is chlorine? It's in group 17. Where is bromine? Group 17. Iodine, group 17. Okay, so you can see then what you can add to that is hydrogen bonded to fluorine. If you have a hydrogen bonded to a halogen, then it's considered a strong acid. So hydrogen bonded to a halogen, hydrogen, then it's considered to be a strong acid, as well as this one and this one. Okay, so those are all considered strong acids, and you must know them and be able to identify them. Okay, those that are highlighted are the ones that we use most often, and the other ones are extra ones that I saw in past papers. Okay, that they do give. All right, chop, page 1. It says there, what is an acid? An acid is something that ionizes with water to form high hydrogen ions, or it also forms, yes, I handed it out last week.
Yes, I know that. But the problem is I don't have a check. So you have some extra.
I will check, but I highly doubt it.
Too many. But did you record this house?
I am recording here.
Oh,
I have one.
Tap it. Who acts first, man? Yeah, who acts first? Actually, I'll break. But it's fine.
I have one Afrikaans.
I used to date Africans. I was there.
All right. Hydronium ions. Okay. Then acids taste sour and in aqueous solution. So when you see that AQ, then it means it can conduct electricity because then the ions are free to move around. And an acid will always have a hydrogen in the formula. If there is no hydrogen, then it's not an acid. Okay. Then I'm not going to go through them now because I gave you the list on the last page. Then if we look at the bases, a base dissociates in water to produce hydroxide ions. A base tastes bitter. They feel slippery and they are soapy in solution. So when you get something that is soapy, it is most probably a base. Now, I don't know if you've ever noticed, but sometimes you speak about bases and sometimes you speak about an alkali. Okay? Now, what is the difference between the two? A base is actually a solid. A base is a solid, and when it is dissolved in water, it's called an alkali. So an alkali will be when you have the aqueous. So both is considered to be a base, but the one we call a base and the other one we call an alkali. And an alkali can conduct electricity because the ions can move around. Then we have different types of bases there. You can see we have oxides, hydroxides, hydrocarbonates and carbonates. Okay, so we said an acid will always have an H and a base can be different things. If it has different things, okay? What we just spoke about on the last page is if it has the OH, then you know it is a strong base. All the rest are weak bases. So this and this and this are all considered to be weak bases. All right, then from grade 9, the bottom part are from grade 9, okay, but I don't think you remember, so I gave you a summary. In grade 9, you did acid and base reactions or half reactions. Grade 9. Yes, sharp. Okay, so those are the reactions that you did in grade 9. This is the general formula, but we're going to practice them in a moment. Okay, so just if you get an acid and a base, when they mix with one another, it will always give you salt and water. If you have an acid and a metal, it will give you salt and hydrogen gas. And we did that with the practical where the acid and the zinc reacted with one another, and we got the hydrogen gas and we lighted up and made a pop. Yes, so it gives you hydrogen gas. So you can write there, how do you test for hydrogen gas? You light the gas and it must make a pop sound.
What is hydrogen gas in Afrikaans?
Say again? Waterstofgas. Waterstofgas. Alright, then if you have an acid with a metal oxide, it will give you salt and water again. And then if you have an acid and a metal carbonate. So if you see the word carbonate, you must have red lights going off. Hello, meneer. Hoekom?
Stemming, verkiesing.
Is dit 'n tie?
Nee, ja, sport het juffrou. Die meneer hier is.
Alright.
Dis 'n sport vir juffrou.
Okay, ek kom. Alright, if you see a carbonate, you must know red lights go off. It gives you a salt and water and gives you carbon dioxide gas. Okay, right. So what I want you to do, please, on the next page, with the help of this, please write the formulas for this. For example, I'm going to do this one quickly. Hydrochloric acid plus potassium hydroxide is going to give you potassium chloride and water. So it gives you the salt and the water. Okay, so please do that. For the red